DataForge is a product for centralized management of the semantic data layer. This type of product can be particularly useful, for example, during migration from one BI system to another, or in environments where multiple BI systems are used simultaneously. Today, I will show you how this product solves the problem of uniform data management in such scenarios. Work in the product begins with describing the semantic layer, and this description is done in the format of a register of measures and dimensions. This register contains the business rules used to calculate all necessary measures, as well as descriptions of all fields used in calculating these measures. Additionally, it describes dimensions, which represent the perspectives or slices in which the business needs to monitor these measures. Related dimensions are combined into dimension groups to mirror business logic and simplify management. Next, the described measures are combined into fact tables and linked with their relevant dimensions and dimension groups. After that, for the logical models of fact tables created in this way, a mapping is performed to fields and tables in the connected data sources. And for use in BI systems, flat data marts are built based on these fact tables, containing precisely the measures and dimensions required for specific reports. First, let's look at a simpler version of a data mart created from a single fact table. As you can see, this data mart is composed of individual required dimensions and measures linked to the sales fact table. We have also configured some filters for this data mart to prevent unnecessary information from being pulled into reports. And we have enabled grouping so that the measure values appearing in reports are aggregated in advance to the required level, in this case, by week. Let's check how this data mart will look from the perspective of report and dashboard building tools. We can view the SQL code used to generate this data mart, and we can immediately execute this code to verify the data mart contents. As you can see, we get a flat table with calculated measures grouped by the necessary dimensions. And now we can create a database view for this data mart, to which reporting and dashboard tools will connect. Here, similarly, we first see the SQL code for creating the view, and we can immediately execute this code to get a ready-made database view for our data mart. Using the created view for this data mart, we can build a sales dashboard like this one. But what if the requirement is not just to analyze sales, but also to compare them against plans? In that case, we need to expand the data mart by adding measures for plans to it. Let's look at a data mart that combines two fact tables, one for sales and one for plans. As you can see, we have the same set of common dimensions, but there are also some new measures from the facts table for plans. Measures from different fact tables can be written into a single flat data mart view either in different rows via union or in the same rows via join. And with such a data mart, we can build a dashboard where measures for sales and plans are compared against each other. But that's not all. Because the data mart pre-processes the data, we can use it to build reports or dashboards in different tools, guaranteeing the same values for the same measures everywhere, in FineBI, in Power BI, in Microsoft Excel, or in any other tool. We can also easily enrich our data marts for reports and dashboards by adding relevant measures or dimensions from the database. For example, we need the city name in French. We can easily find the corresponding dimension in the already configured fact tables. Verify that it is exactly what we need. and add it to the Data Mart. After that, we can update our Data Mart's view in the database. And now, this dimension is immediately available for use in our reports and dashboards. To test it, let's link the city filter to our new dimension. As you can see, data from our new dimension was automatically pulled into the dashboard. And in doing so, we didn't have to write any scripts ourselves or ask data engineers for help. Moreover, this uniform approach to data marts lets us control the business logic for measure calculations centrally and transparently across all reports and dashboards. Let's consider a scenario where the business rules for a measure in our data mart, such as gross sales, change. And now we need to include paid pre-orders with an operation ID of 2 in its calculation. To reflect that change, we update the measures formula. Next, we need to update the database view for our data mart. By reviewing the generated SQL code, we can confirm that the new calculation logic has been applied. Now, let's check how this update propagated to our dashboards. First, we see the updated values in FineBI. The same changes are reflected in Microsoft Excel. And finally, Power BI shows identical updates. So, we achieved consistent calculation adjustments across all our reports and dashboards without having to modify their individual settings. And again, we did not write any complex scripts ourselves or ask data engineers for help. Now, to wrap up, let's recap what we have accomplished in this demo. First, we explored the core principles of working with the data warehouse in DataForge. Second, we demonstrated how to create unified data marts instantly available across various BI tools. Third, we examined the capability to independently manage calculation logic and data composition for BI tools. Finally, we confirmed that this approach guarantees consistent data across all reports and dashboards, even in heterogeneous environments. This concludes our demonstration. Thank you for watching.